that when you blow up a balloon, it fills up with air, and the pressure would be big enough that when you let go, the balloon would shoot across and it would hit the structure over and sometimes still have air in it. But if it does, then the air would just shoot out because it will find your easiest exit way out of the compressed space.
I think a square is a perfect shape because mine was a square and it held together nice and firm and it didn't break. There are better shapes other than a square that hold together better, but I think a square holds together pretty good. What did you learn about air compression?
We learned that the more compressed air inside a balloon, the more pressure there will be.
And the more pressure there will be, the further and the more powerful the balloon will shoot through the air. That's what we learned. What did you learn about air compression today?
I learned that air has a lot of pressure exerted into it, and that the more it's compressed, the farther it will shoot a balloon, and that the reason why it shot the balloon was because the air was pushing at the balloon, and when we finally let it go, it went off.
We planned out our parachute. After that, we had to get the materials. We built it, and we had the washer. We connected it from the strings, and we tested it. After that, our buddies made some sort of box to help to prevent the egg from cracking.
3, 2, 1. How did you build your egg container? I took 3 sponges, 1, 2, 3, and I cut a hole in the center sponge. And I put the egg in, and I filled it with cotton balls, and taped it, and stringed it with, and so these two cushion the middle one. Did your egg break? No. Okay. Why not? Because these two cushions cushion the egg like a pillow. So it's so comfy, you can almost sleep on it.
The purpose of the experiment was to see which out of the 3 types of airplanes would fly the farthest. There was a Delta, a Dragonfly, and an Arrow. While the controlled variables was the paper and the design we had, our manipulated variable was how hard or soft we were throwing it, and our responding variable was how far it traveled.
The first thing we did was research what type of airplane we were going to use and what materials and what kind of paper, and then we started to build them, and after we did that we put them in the launcher. The manipulated variables were how big the airplane was, the materials of the airplane, and the design. The speed of how the airplane was being thrown.
Excellent. And what was the responding variable?
The distance of the airplane.
And did you change anything in your design to make it fly further?
No.
Okay. Or what made your airplane successful?
How it glided through the air because my wings were kind of tilted up.
What are you guys changing from your last one?
We're just
making just an entirely different one.
A different design? And what's different about it from your first one?
It's going to take like 12 minutes instead of 5 minutes.
For part of our Transform initiative, we wanted to include a cross-curricular component. We invited our art consultant, PJ Crummins, to introduce our students to components of how art meets science. The students experimented with contour drawings focusing on different things that fly.
Awesome concentration. You guys are doing a great job of checking the image and double checking yours.
In their Transform groups, students were then able to explore temporary art using a variety of materials and created their own flying device or creature.
Cool.